We'll go with one more chapter, that is carboxylic acids, which is there in your class 10 ICSE. Now, what is carboxylic acids? Actually, they are also a kind of organic acids which have the properties of acids. So, carboxylic acids actually they are derived from alkanes. So, we can say it as organic compounds that are compounds of alkanes because they are derived from alkanes and containing the carboxyl group. So what is carboxyl group? That is COOH group. We know that alkanes, the general formula alkane is CnH2n plus 2. Now suppose if we take one hydrogen out from here, then it becomes CnH2n plus 1 including COOH. That is, so we can say that they are derived from alkane, and this is we write as RCOOH. Now if n equals to 1, if we write n equals to 1, the formula becomes C1H3COOH. See here. So what is this C1H3COOH? We can write here 2 carbon atom is there. So this is what we say is acetic acid. Now the very first form of oxalic acid, that is we can derive like this: C double bond O OH. So what is this? We have single carbon, so we can write it as methanoic acid, which is also called formic acid. In this way we can derive. So therefore the general formula becomes CnH2n plus 1 COOH, and the structural formula would be in this pattern. Again, carboxylic, any organic compounds that contains single COOH we say as monocarboxylic acid, or if we have 2 COH then it becomes di. Let us find out the structure of both two carboxylic acids. Here we have a single carboxylic acids, that is methanoic acids, or we can say also formic acids, and here also we have a single carboxylic acid, that we have ethanoic acid or acetic acid. As I have said you earlier that there may be two types. One more is if compound contains 2 COH, then it becomes oxalic acids, which also we can return as ethane dioic acid. Now let us go with the structure of acetic acid. This is a very important question. Often it appears in ICSE exam. That is, draw the structure of ethanoic acid. So what is ethanoic acid? The formula of ethanoic acid is CH3COOH. So how we can write it here? We can write it here C double bond with O, single bond with OH. So we got it COOH. Then it here is CH3. Draw it in this way and write it here H. So this is CH3COH, that is ethanoic acid. Next we will have a very important structural formula of ethanoate. What is ethanoate? Ethanoate, the formula of ethanoate is CH3COOC2H5. So how to draw the structure of this? First we will draw this structure, that is C2H5. Let us take C2H5, this C2, this H, CH3, C2H5, 1, 2, 3, 4, and this is 5. Then we have to draw with this single bond O. This comes with this, that means COO we have already completed. Then CH3, this is CH3. In this way you have to practice sodium sorry, not sodium ethanoate, it is only ethanoate. Next question is, what is glacial acetic acid? The anhydrous acid on cooling, it forms a crystalline mass resembling just like ice whose melting point is 17 degrees Celsius. Hence it is called glacial acetic acid. Now the questions, whatever I am going to write down on the board, such type of question often comes in examination. Number one, what do you observe when acetic acid reacts with? Number A, litmus. Since it is an acetic acid, so it turns blue litmus turns into red. Next, when acetic acid reacts with magnesium, there appears a brisk appearance of its hydrogen gas is evolved with magnesium acetate as well. Then when it reacts with alkalis like sodium hydroxide, since it is acid, so it naturally forms salt and water. That is sodium acetate, which is salt and water. When it reacts with carbonates or hydrogen carbonates, it liberates brisk effervescence of carbon dioxide. So we have the equation in this way, and it's a very important reaction heating with phosphorus pentoxide. It forms acetic anhydride as it loses water molecule. So the reaction is in this way, and hope so you must know this reaction, as this reaction may not be in your syllabus, but still this is a very important reaction to know it right now. So when it reacts with alcohol, we have already read regarding the esterification. So here ester is formed in presence of concentrated H2SO4 with a sweet smell. So here we see this CH3COO. Actually this portion and this portion becomes water, and rest this becomes with this, that is ethyl acetate plus water. Next, since we can see from here there is a reversible reaction can take place. So how reversible reaction is prevented here? By using concentrated H2SO4 when the reaction is just about to complete by removing water. Reduction. A strong reducing agent like lithium aluminum hydride, when it will reduce CH3COH, that is ethanoic acid, to ethanol. Next, what happens when acetic acid is added to neutral FeCl3 solution? It becomes wine red color is formed. This is also a test for it.